Hello, my dear student. Myself, Dr. Sumir De, Assistant Professor and Teacher in charge of Mathematics section under Department of Basic Science and Humanities, Asansol Engineering College, Asansol. This is my 8th lecture under module number 3. Paper name is Mathematics 1A. Paper code BSM-101 for Computer Science and IT. This is my 8th lecture based on solution of a system of linear equation. Subtopic is matrix inverse method. In this topic, solution of a system of linear equation, there are different methods we have. One is Cramer's tool, another is matrix inverse method, third is Gauss elimination method, fourth is Gauss-Jordan method. In my last video, that is lecture 7, I had discussed Cramer's tool, okay, based on determinant concept, by which we can solve a system of equation, and where we can discuss where I had discussed about the unique solution, no solution, and infinite many solution. Now today's topic is matrix inverse method, and this is the matrix inverse method is a particular method. Why it is called particular method? Because matrix inverse method by which we can find only unique solution. Correct? We can't say anything about no solution or infinite many solution. Correct? If solution exists, we can find unique solution by using matrix inverse method. Now try to understand. So this is the basic difference between Cramer's tool and matrix inverse method. In Cramer's tool, you can explain all type solution, but in matrix you can explain only unique solution. No information about no solution or infinite many solution. Okay, let's see. Matrix inverse method. Let us consider a system of 3 linear equations in 3 variables. Linear equation, same. Why it is called linear? Just to check here, in this system of equation there are 3 variables, x1, x2, x3. Sometimes you can see x, y, z also. Any other variable you can see. Okay, so that's why this is called 3 variable system of equation. And why it is called linear? Because all variable power are 1, x1 to the power 1, x2 to the power 1, x3 to the power 1. So that's why this is called linear equation. Why it is called system? Because there are 3 equations, so that's why this is called a system of linear equations. Okay, now this system of equations can be written in the following matrix form. This is vital. This step is very, very important. Ax equals to b. What is A? A is a coefficient matrix. What is X? Variable matrix, column, variable column matrix. What is B? Is a constant matrix, column. Try to understand how to find A matrix. Just from here it is clear. A first column of A matrix, A11, A21, A31 is the coefficient of this column is coming from coefficient of x1. Second column, that is A12, A22, A32 is coming from coefficient of x2. And third column, that is A13, A23 and A33 is coming from coefficient of x3. So this step is very, very important. So I'm considering this Ax equals to b as the equation number A, small a. Okay, from A we get the solution of the given system of equation by x equals to A inverse b. So here you know x, you know b. What is your unknown? Here main unknown is A inverse. So already you know how to calculate A inverse. Again I will discuss how to calculate A inverse, where A inverse equals to adjoint by dt. So if I know A inverse, I should substitute here. Then I should multiply with the B column matrix. Then whatever I will get. So this is the solution of X. That is the solution of the system of equations. Okay. So this is all about matrix inverse method. Now try to understand. So here I'll try to explain algorithms, means step-by-step process, how to implement matrix inverse method to solve a system of equation step by step. Step number 1, rewrite the given system of equation in matrix form. Ax equals to b. Already I have discussed what is a, what is b, what is x. Okay, and then x equals to a inverse b. First you write down whatever the system of equation is given. First you write down ax equals to b, and then you write down x equals to a inverse. This is your first step. Step number 2, calculate the determinant of matrix A, that is det A. After getting this, you have to from here you can understand what is your A matrix. Then you have to calculate determinant A value, because this is very, step number 3 is very step number 2 is very important. Then step number 2, if determinant A is equals to 0, it means the matrix A is a non-singular matrix. Already you know, if matrix A is non-singular matrix, so we can't calculate A inverse, as well as the solution. If we can't calculate A inverse, so we can't find X. So that's why the solution of the given system of equation does not exist, and stop the calculation and conclude the result. That solution does not exist. Clear? Solution does not exist means what? Maybe unique solution, maybe infinite, maybe no solution, maybe no solution, maybe infinite solution, but you can't calculate. You can't conclude anything. You can't say solution does not exist. That's all. Clear? Now, if determinant A not equals to 0, then matrix A is a non-singular matrix. It means A inverse exists. Now go to the step number 4. Clear? I repeat once again. Step number 3 is very important. If determinant A is equals to 0, it means the matrix, coefficient matrix A is a non-singular matrix. It means we can't calculate A inverse, because already you know, to find A inverse, we have a formula, adjoint A by det A. If det A is 0, then your A inverse become undefined, so you can't calculate. So that's why the solution of the given system of equations does not exist, and stop the calculation. Okay, this is the first step. Second step, if determinant A not equals to 0, it means your coefficient matrix A is a non-singular matrix. If non-singular, then A inverse exists. Okay, and go to the step number 4. Next, step number 4. What is your target? Our target to find A inverse. So what is your formula? A inverse? A inverse equals to adjoint by det A. So in this step 4, we have to calculate adjoint by A. So already you know A11, A12, A13, A21, A22, A23, A31, A32, A33. What is this? A11, A12, these are all the cofactor of determinant A. Okay, when you transpose it, that means this row represent in terms of column, and this is called adjoint of A. Adjoint of A. Okay, so what is A11? From this cofactor can be managed by using this form, that is A22, A23, A32, A33. From the given determinant, you can substitute the value of A22, A23, A32 and A33, and we can calculate the value of A11. Similarly, A22, A12, similarly A13, A21, A22, A23, A31, A32, A33. After getting this all cofactor, just substitute here and then transpose it, and you will get the adjoint. Clear? So these are the formula by which you can calculate all 9 minors of the determinant A. After getting this all sorry, all these are the 9 cofactors by which you can cofactor from of determinant A. After getting this all 9 cofactors, just you substitute here, then transpose it, and you will get your adjoint. Clear? So this is all about the step of adjoint. Okay, and step number 5, after getting your adjoint, so you know the solution of the given system of equation is Ax equals to A inverse B. What is A inverse? A inverse equals to adjoint by data. What is X? X is a variable column matrix for variable. And what is adjoint? This is your adjoint, and determinant 1 by determinant B. Okay, so if I, then we should multiply with this and find the value of x1, x2 and x3 and stop. So these 5 steps, if we can follow, then we can find the solution of a system equation by using matrix inverse method. Okay, now try to understand these steps, this method stepwise with some example. Try to understand. Solve the system of equation by matrix inverse method. What is your equation? 2x1 plus x2 plus x3 is equals to 5. x1 minus x2 is equals to 0. 2x1 plus x2 minus x3 is equals to 1. So I'm considering this question for one important point of view, just to check in this first equation how many variables you have. 3 variables, but here you have only 2x1, x2. What about x3? There is no x3. Okay, so first you have to rewrite this just to check answer. The given system of equation can be written as 2x1 x2 plus x3 is equals to 5, as it is first equation. Second equation, x1 minus x2 plus 0 into x3. Okay, always you should write which variable is missing, just you represent with 0 coefficient. Okay, next third equation, 2x1 plus x2 minus x3 is equals to 1. Clear? If your given information all are okay, no need to write this information, you can start directly step 1. Okay, now step number 1, already you know step number 1. In step number 1, what you do? You have to rewrite the system of equation in matrix form. Now you check. Now we want to rewrite, this is a coefficient matrix. This matrix first column is coming from coefficient of x1. Please check 2, 1, 2. Please check 2, 1, 2. Coefficient of x2 1 minus 1 1 1 minus 1 1. Coefficient of x3 1 0 minus 1 1 0 minus 1. This is a column matrix for variables x1, x2, x3 is equals to right hand side part 5 0 1. Is it clear? Here I'm considering this is equation number 1. So this is all about the first step. Okay, clear? Next, step number 2. Step number that is ax equals to b. What is x? X equals to A inverse b. What is A inverse? Adjoint by data. Where A is equals to this, you know, 2 1 2 1 minus 1 1 1 0 minus 1. What is x? Variable. Column matrix for variables x1, x2, x3. What is b? Capital B is a column matrix 5 0 1. So this is all about the first step. What is the second step? To find a determinant value. Now determinant of A, that is 2 1 1 1 minus 1 0 2 1 minus 1 is equals to 2 into minus 1 into minus 1 minus 1 into 0. So this one minus of minus 1, then 1 into minus 1 minus 2 into 0, this one, plus 1 into 1 minus 2 into minus 1, this. So from here 2, and this is 1 minus 0 minus 1, then minus 1 minus 0 plus 1, from here 1, and from here plus 2. Ultimately your value is 6, that is not equals to 0. So already you know If your determinant value is not equals to 0, means determine a matrix A is a non-singular matrix, A inverse exists. So that means A matrix in step 3 you should conclude the what type of matrix A is. So write down. So here A matrix is a non-singular matrix, therefore A inverse exists. Clear? So our third step is over. First step, I repeat once again, first step is all about the representation in matrix form. What is A, what is X, what is B, you write. And step 2, find the determinant value. Step 3, conclude about the matrix, singular or non-singular. If non-singular, write down A inverse exists like this. Okay. In step 4, we want to find the adjoint. So already you know the formula. This is your A11, A12, A13, A21, capital A21. That is all cofactors. A11, A12, A13, A21, A22, A23, A31, A33, A32, A33. So already you know the formula. That is what is A11? A11 is equals to plus A22, 23, A22, A23 small elements, A32, A33, this one. Clear? Okay. And what is this? 1, 2 and 0, 1. Clear? And what is this? 1, 2 minus 1, 1. Okay. Similarly, you can calculate A21, this is capital cofactor A21. How to calculate? Very simple. This and that and this and that. Clear? So already you have a formula. Just you have to substitute and find the result. Okay. So this is all about the calculation of adjoint. Clear? Any doubt? So suppose you want to calculate this. This is means this is the cofactor of A, cofactor A33. How to calculate A33? For this means 2, 1, 1 minus 2. Just to check. 2, 1, 1 minus 2. Another important message I should share with you. Just you should write, when you can calculate, consider this is a minor. When you consider sign, this is called cofactor. So first you have to write directly plus minus, alternative sign, plus minus, plus minus, plus minus, plus minus, minus. Okay. So after getting this calculation, what you have, please check. Adjoint equals to 1, 2, 1, 1 minus 4, 1, 3, 0 minus 3. So this is the main part about the calculation. Adjoint. If adjoint part is correct, then automatically the rest of the part becomes correct. So be careful about this. So already you know how to calculate A transpose. That is, suppose one matrix is given, you want to transpose its you want to find its transpose. Then what do you do? Your row you have to write as a column, like 1, 1, 3. Write as a column 1, 1, 3. 2, 4, 0 as a column 2 minus 4, 0. 1, 1 minus 3 as a column 1, 1 minus 3. So this is our adjoint. Clear? Okay. Now from 2. Now from 2 means this one. X means this. A inverse means adjoint by date. And what is B? You know that now. Now from 2, this is your X, A inverse and B. So X means variable matrix. A inverse means A inverse means adjoint by date. This is your adjoint, that this is coming from here. 1, 2, 1, 1, 2, 1, 1 minus 4, 1, 1 minus 4, 1, 3, 0 minus 3, 3, 0 minus 3. What is this? This is a determinant value. That is adjoint by date. Correct? And matrix. This is your B. What is B? 5, 0, 1 as a column matrix. Okay. Now multiply this. 1 into 5. How many row you have? 3. How many columns you have? 3. So how many row you have here? 3 row, and how many columns? Single. So that means this matrix column and this matrix row is same. So that's why you can multiply. So can calculate 1 into 5 plus 2 into 0 plus 1 into 1. This line, first line. Next, 1 into 5 plus minus 4 into 0 plus 1 into 1. This line, second line. 3 into 5 plus 0 into 0 plus minus 3 into 1. This one. So after simplification, you have 1 by 6 outside like this, and 5 0 plus 1, that is 5 0 plus, that is 6, and from here 5 0 1, that is 6. Okay, and from here 15 0 minus 3, 15 0 minus 12, that is, what is the column form you have? 6 6 12. If I divide each and every element by 6, what is left? 1 1 and 2. So this is 1 1 and 2. So ultimately we have x1 is equals to 1, x2 is equals to 1, x3 is equals to 2. So this is the way out to find a system of find a solution of a system of equation by this matrix inverse method. So ultimately you should write the required solution of the given system of equations is x1 is equals to 1, this one is coming from here, x2 is equals to 1, this is coming from here, and x3 is equals to 2. So this is all about the matrix inverse method. Okay, thank you.